your hand. We're going to be going through a number of slides, and we'll ask for questions as we go along and try to deal with questions in a batch as we move through this presentation today on springs and springs-dependent species in the desert Southwest. We hope everybody can hear and see the screen. If not, we sent you an email. You can listen in on your phone line and view the presentation that we sent you as a PDF. So again, please, if you have any questions, raise your hand by clicking the little icon on your screen. And if it's a question that warrants group attention, we will unmute you and enable you to ask your question directly. Other questions we may end up addressing through texting or through email after the presentation. But please don't hesitate to type in a question at any time into the control panel, and we will try to address them at the end of each of the major segments of the presentation. Anybody that's not comfortable having their name show up on the screen here, please let us know, and we'll take your name off so that you won't be visible. Right now, the participants on the list include members of the U.S. Forest Service, BLM, the National Park Service, the BIA, the Fish and Wildlife Service, researchers, including recognized experts on the taxonomy of springs-dependent species. We have representatives from various states in the Southwest, as well as Native American tribes and other individuals and NGOs. So this is quite a interesting group of people to have come together on the subject of springs and spring-dependent species, and we're really glad that you were able to join us today. At this point, we have about 3/4 of the people who signed up for the presentation online. So I think I'll go ahead and start the overall presentation. And my name is Larry Stevens. I'm the Curator of Biology and the Program Manager of the Springs Stewardship Institute here in Flagstaff. And I'll be presenting today along with Jerry Ledbetter. She is our Information Manager and a Geographer here at the Springs Stewardship Institute. Our staff is also assisting us today, Marguerite Henry and Kelsey Johnson. If you have any questions at this point, please don't hesitate to either raise your hand or type your question into the screen at the bottom right of your control panel. So welcome to the Spring Stewardship's presentation webinar on springs and springs-dependent species of the Desert Landscape Conservation Cooperative. The abbreviation for that is DLCC, if you need another abbreviation in your lexicon. We will be moving through this presentation today. This presentation has been sent to you as a PDF, and so you'll be able to see it there. So first, a little bit about Spring Stewardship Institute. Our institute is an initiative of the 501c3 nonprofit Museum of Northern Arizona in Flagstaff. So we're a private entity, and Spring Stewardship Institute was established to improve understanding of springs ecology throughout the world, to educate the public and resource managers about the importance of springs and spring stewardship, and to partner with other organizations, agencies, tribes, and researchers to improve the understanding and management of these critically endangered ecosystems. Okay, Max Taylor has a question. And Max, it might be a good idea to type your question into the box there as well, just in case we can't communicate with you. Hearing no response here, I'm going to move on. What is the DLCC? This is a vast land area of the desert Southwest, 217,000 square miles of the desert Southwest, stretching from southeastern California, including Death Valley and the Amargosa Valley of southern Nevada, and down through the southern half of Arizona, the southern third of New Mexico, and the southwestern corner of Texas. The DLCC is one of 17 landscape conservation cooperatives established in the United States to improve management of resources across the country. And this is relevant to us because the spring stewardship is a national issue. It's not just an issue in the arid Southwest, and hopefully we'll be able to take what we learn here and move it to a larger national scale scope in the future. We have an interactive map and a list of counties in the DLCCs in this DLCC on the SSI website. That's at www.springstewardship.org, along with a lot of other information about Spring Stewardship Institute. So there's a vast landscape, many hydrologic basins within it, 141 HUCs, 8-digit HUCs within this landscape, and that's the framework in which we're talking about springs and springs-dependent species. The Spring Stewardship Desert LCC project entails 4 tasks. The first task is to map the distribution of DLCC springs in the U.S. portion of the DLCC and to make that information available to land managers through secure online resources. That's a non-trivial task because there are thousands of springs in this landscape. Task 2 is to determine the biological diversity and distribution of springs-dependent species, including plants, macroinvertebrates, and vertebrates throughout this vast landscape. Again, this is no small task because we guess that there may be thousands of springs-dependent species that are poorly known in the landscape. Among the 52 species that are candidate species right now for the Fish and Wildlife Service, a total of more than a quarter of them may be springs-dependent. Those are species that are being newly considered for listing as endangered. So within the DLCC, 1/4 of the species that are being considered there for listing may be springs dependent. Many species are springs dependent in the Southwest. Third task is to conduct outreach through webinars such as this, through workshops, courses, websites, and communications on springs and springs-dependent species. The task 4 that we're proposing here is to develop a climate change risk model, and that's tying together threads of information from tasks 2, 3, 2 and 3 to bring this attention to climate change risk on springs in the DLCC. Why are we concerned with springs? Springs are surprisingly abundant in the Southwest. The topographic diversity of the Southwest with the exposure of the edges of aquifers means that springs can pour out in rather great numbers. Arizona is the second most arid state, has so far as we can tell the highest concentration of springs. Nevada is right up there as well, and that makes springs rather common features of the American Southwest. The economic values of springs are surprisingly enormous, both as recreation sites and for bottled water, as well as for the endangered species and rare species that they support as biological hotspots. The several dozen Native American tribes within the landscape all uniformly regard springs as being sacred sites, as being important sites in the landscape, critical to their cultures, to their tribal histories, and so there's a lot of anthropological value and concern about springs. Given all this importance, it's surprising that springs are as threatened as they are and poorly studied as they are. Springs are often degraded and poorly managed, simply by neglect in many cases, but oftentimes springs are used for human goods and services, and there's an intentional management plan to manage them. Here at SSI, we suggest that when springs are being managed, there still may be some ecological functionality to be supported, and maybe it's a good idea to look at the ecological side of the story as well as the human use side of the story in management of springs. The good news too is that if the aquifer supporting the spring is in pretty good shape, then restoration is relatively easy. And there's been some remarkably wonderful stories about springs restoration here in the Southwest. All right. some of the research we're doing on springs here at SSI and with our colleagues at Northern Arizona University and elsewhere is to look at the array of springs types. In the Southwest, we've identified 12 springs types. These are they range in from gushing outpour, gushets we call these kind of springs that pour out of a cliff face, to hanging gardens, to hill slope springs, pool forming springs, which are typically places where unique species and endemic species are found, cave springs that emerge from caves, and then very important in the Southwest are wet meadows, which are called cienagas at low elevation and groundwater dependent fens at high elevation. These are very much hotspots for biodiversity of plants and invertebrates and amphibians such as leopard frogs. So there's a big array of springs types in the Southwest. Springer and Stevens, 2008, we've documented these types, and also note that there are a rather large array of microhabitats associated with some kinds of springs that allow kind of remarkable quilts of species, mosaics of species to coexist, and that helps explain why springs are biological hotspots. So at this point, I'd like to turn the discussion over to Jerry Ledbetter, our information manager here at SSI, and to talk about the first task. Jerry?
Hello. We have been working with mapping springs across Arizona, specifically, for 4 years, going on 5 years. The primary problem we're dealing with springs is that mapping is incomplete. It's inaccurate. There are a lot of springs that are unmapped, even in the second driest state in the country, Arizona. We don't know where the water is, and it's kind of ironic. What we're finding is that no data source is complete, and each contains data that are not included in the others. There are, we've compiled then from a lot of data sources, including the NHG database, the State Land Office, various agencies. Okay, I'm being told to speak up. Is this any better at all? Okay. Maybe
Continue.
I'll switch. Is that better?
I can't tell.
Give me your... Okay, I'll try Larry's headset. Can you hear me now? Okay. I'll assume that this is working because it was working for Larry. So springs are very poorly mapped. Mapping is really incomplete, inaccurate. Even in Arizona, the second driest state in the country, springs are poorly mapped. When we pulled the first layer from the Arizona State Land Office, there were 5,000 springs on it, and I thought that that looked pretty complete, and we realized that Montezuma Well isn't on that layer. So what we did is we started compiling from multiple data sets from the NHD database, which usually provides the bulk of the information. We got data from individual agencies, from EIS documents dating back to the 70s. We scanned topographic maps, and that's kind of a tedious task, but we pick up a lot of springs that way that aren't on any other layer. We've also collaborated with conservation organizations and individual researchers. So we have a fairly good understanding of springs distribution across Arizona. And you can see this belt of clustering across the center of the state. We know that this isn't a complete layer, but it's closer than we had from any other source. And you can see when we start pulling together these multiple data sets and trying to reconcile them, you can kind of see the problem here. Mangum Springs, there's a big clustering of springs across this area. And there are several springs in there, but there aren't as many as it looks like there are. And then down toward the left, Mourning Dove Spring shows another example of a problem that we deal with, where Mourning Dove is spelled 2 different ways. It's mapped in 5 different locations on the data sets. So that's a huge task. And so we're looking at a much larger land area, and that's quite a challenge. But we've been working on it for a few months now. We have 13,504 springs within the DLCC, 7,460 within Arizona. We have an interactive boundary map available at springstewardship.org. If you want to, you can zoom in and see where this boundary is relative to your land unit. The second part of task 1 is to develop secure online applications so that people can access this information. And Jim Hurria from the Spring Mountains NRA in Nevada gave us permission to show this this application that we built for him as an example. And this shows all the springs that we surveyed during a 3-year project with Northern Arizona University. And it shows the inventory status of each spring, and you can click on a spring and open up information about it. You can click on a link and open up the complete report. And also this shows the perimeter of the Carpenter Canyon fire that occurred last summer. And I was updating this layer every day or so so that people collaboratively could see what the effects were on springs in that area. You can zoom in on these interactive maps and apply different base layers and really get a lot of information from this. And you don't have to know a lot of GIS. You don't have to know any GIS to use one of these maps. The next part of this project is to develop an online application for the non-spatial data. When we survey a spring, we get a lot of information from flow, water chemistry, flora, fauna, images, the assessment scoring, and compiling all this information into one accessible, comprehensible database has been an ongoing project. We are migrating our database to an online application that will be accessible using a username and a password. And we should launch this within the next month or two for beta testing and feedback. There's great search capability with this. You can search by name, by land unit detail, a quad or a HUC. You can also enter latitude, longitude, and search for all the springs within this data set. To access this information will require a username and a password. We have user levels varying from just read-only to super administrator, which is necessary to administer the account. The administrator level would have full access to the information. That would typically be the land manager. We have the ability to mark sensitive sites, whether they have sensitive data or just the location itself is sensitive, and those require special permissions. We've put a lot of time into this, into developing a fairly sophisticated way of granting permissions to secure the data. The permissions can be set by land unit and by project and also by other parameters, including the site sensitivity. Are there any questions about this part of the project? This is basically mapping the distribution of springs and making the information accessible using online applications. Joseph? Yeah, unmute him. Hi, Joseph. So Joseph asked why the distribution of sites is so unequally located across the state. Yes, it definitely has to do with the geomorphology. What we're finding is that there's heavy clustering of springs along escarpments, and that's why that big belt of springs across the state of Arizona is there, because that's where the Mogollon Rim is. And there are just a ton of springs all across there. Those escarpments expose the aquifer, and so that's where we find a higher clustering of springs. Okay, if there are, and there was one other question that I think Larry should answer. and we'll defer that one. Oh, as Chris Murphy is asking about linear spring features, such as outflow channels. We do not have that in our spatial layer yet. The thing about springs is that they are, springs just haven't been studied as much as streams and rivers and lakes and oceans. They've kind of fallen through the cracks for research, for administration, for protection. So what we're finding is a lot of times there's a stream that's included in a GIS layer, but it appears out of nowhere, and there's actually a spring at the head of that stream, and we find that a lot. So we're not including right now those line features within the geodatabase that we're developing, partly because a lot of that information is accessible already. I think we will eventually move into that. The thing that we are tending to map more now, and I know that the National Forest Service is working on this too, is mapping polygons associated with springs. For very large spring sites where there's a large habitat associated with it, we have a polygon layer where we can house that information. Okay, I'm going to turn it back over to Larry. Thanks a lot.
All right, excellent. Tim Fry had a question that was, are we working with artesian springs? Well, I should have mentioned right at the beginning that our definition of spring is any place that groundwater is exposed at the Earth's surface. So, our interest in springs includes springs that are artesian, springs that are wet meadow forming. They may not be flow exposed at the surface, but the ground surface is wet. If you look on our website, you'll see an array of 12 different spring types that we have identified in the Southwest. Seeps are simply small springs, so we include them in our definition of springs. But it's where groundwater reaches the surface of the Earth, and it usually flows, but not in all cases, such as at a place like Devil's Hole, Nevada. All right, I'm going to describe the second task here, which is to determine the biological diversity and distribution of springs-dependent species in the DLCC. What is a springs-dependent species? Well, we consider a springs-dependent species to be an organism with at least one life stage that's dependent on springs outflow. And the kind of core question here is, will this species exist without the springs as habitat? And if the answer to that is no, then that's a springs-dependent species. That can be, some of those organisms can have a relatively brief period of their time at the spring, but if that's critical to their whatever imprinting movement through a stream for spawning habitat, that can be quite critical. Is there? We got a recent question here. Is there a required residence time for springs water to be considered as groundwater? And I'll talk about that one, I guess now, because that's a bit of a core question. The duration of time in the ground for groundwater varies really greatly, from less than a day to, in the DLCC, more than 10,000 years. Vinograd studies in southern Nevada talk about 10,000-year flow paths for some of the springs coming out in southern Nevada, and we have examples of springs in the DLCC that are very brief in terms of just short residence time as well. So, good to understand that there is great variation in residence time. Good to understand that long-term residence times means that the damage that we do to aquifers now might take thousands or tens of thousands of years to restore. So right now we haven't put a prescription on residence time, but that remains a very active arena of research for the Desert Southwest. Okay, back to the springs-dependent species. We've defined springs-dependent species as species that have one life stage dependent on springs outflow. What we're doing in the strategy here is to develop species lists for plants, macroinvertebrates, and vertebrates that are springs dependent. We compile a list. Generally, that's a list for the DLCC states, try to cut it down as much as we can before we send that off to expert taxonomists and expert biologists to evaluate. One of the beauties for me as a biologist in this program is I get to work with people like Don.
Welcome to GoToWebinar, Webinars Made Easy.
Focused on springs-dependent species and just know more than most of us could ever hope to about some of these taxa. So we'll develop these lists, vet them through the experts, and return that information to the database, the website, subject to the same levels of security where the information is not already public. Databasing and setting the stage for accurate mapping of these species is the next process. That's an ongoing process, and our expectation is we may end up with hundreds or thousands or more than 1,000 species that are springs dependent in this landscape. So we'll compile lists. We hope to be able to georeference as many of them as we can, and that's going to be an ongoing process. We're going to use the results of this Task 2 in Task 4, as we'll talk about in a little bit, to describe the climate risk modeling effort. So with that, I'll give you a couple examples of the biodiversity we're talking about. Our rough estimation of springs dependence for species in the U.S. is that 19% of the animals and plants in the U.S. are probably springs dependent, at least at some stage of their lives. This is especially true for fish, amphibians, aquatic invertebrates, riparian invertebrates, and some plants. Springs can be long-term evolutionary theaters, if you will, for the emergence of endemic species, and that's certainly the case of some of the springs in the DLCC. 19% of the endangered species showing up on a total habitat area that is unmappably small means that conservation of springs really can be a tremendous benefit to the conservation throughout of those species throughout the landscape. We know that there are hundreds, if not thousands, of often rare springs-dependent species that have not been listed, have not been studied. Some of them are entirely new to science. Some entire families or larger taxonomic groups just have received very little taxonomic inquiry so far. And examples of some of these kind of species are spring snails and pupfish. There are about 170 species of hydrobiid spring snails in North America, dozens of pupfish species. These are found, almost all of them, in springs habitats, either right in the sources or in the springs outflow channels. So those are examples of species with that are springs dependent and highly diverse. The mollusk family Physidae, the turbularian flatworms, rather many stoneflies that have yet to be described are showing up as springs-dependent species as well. So it's really a vast biodiversity of species that have yet to be recognized for their springs dependence. We're working with NatureServe in this project to perhaps even include springs dependence as a habitat descriptor for those species, so that'll be clearer in the future. As an example of an ecosystem in which, a spring-fed ecosystem in which very complex food web dynamics have taken place, is the case of Montezuma Well in central Arizona, which is in the DLCC. This is a landscape that has a springs system that has the highest concentration of unique species of any point in North America, and it's largely endemic. There's an amphipod shown in the middle of this slide that is fed on during the day by aquatic insects that are visually feeding predators. The water scorpion there is endemic to Montezuma Well. The two amphipod species are endemic. At nighttime, there's a horde of leeches that emerge up out of the ooze in this 60-foot deep pool of water to prey on the amphipods. One of the genera of leeches coming up out of that horde is unique to the world, found only in Montezuma Well. So close to 10 or more species unique to Montezuma Well, found nowhere else on Earth. and the trophic structure here is largely endemic. So it's really a remarkable story of how complex the food webs can be in a large, stable springs ecosystem. This is documented by Dean Blinn in our book on arid land springs in North America that Vicki Moresky and I published in 2008 through the University of Arizona Press. So springs are hotspots for biodiversity, rare, sometimes endangered species, complex ecosystems, and we are looking forward to compiling these lists. We'll post those on the website for your review as well, and any information you have to share with us on those species will be most welcome. Okay, at this point we'll have Jerry Ledbetter take over the discussion of Task 3 and the Desert LCC Springs Outreach component.
Okay, I'm trying actually a different headset, and I'm hoping this works better. Let me know if it doesn't. Oh. Okay, can you hear me? I hope so. I'm trying a new headset now. There have been a few questions, and I think I've been more or less answering them. Please continue to ask if, and actually, Rebecca, if you want to just voice a question, then we can do that too. Just let me know, or raise your hand, and we'll unmute you, and we can discuss that. Task 3 of this project is essentially outreach. We are partnering with spring stewards, conservation organizations, tribes, with training in ecological inventory assessment and planning and monitoring, also restoration of springs. We are available for individualized consultation, as we have with Jim in the Spring Mountains. We are planning to conduct a workshop. Right now we're looking at the Las Vegas area in September 2014, and we'd be interested if anyone would like to attend that. Our 2-day workshops are described on our website, and they include training for inventory assessment of springs, and they involve some hands-on field work. So let us know if you'd be interested in attending one of those. We will be having quarterly webinars like this with different subjects each time. We'll be providing updates and training in using these online tools and further discussion with partners. We'll also, we have some university courses that we've been involved with. One we're planning with Prescott College in this summer, a block course with Prescott College students. We also have a lot of information at our website with updates. We have our protocols on there. We have links to the maps, to the DLCC mapping application that may really help you figure out what part of your land area is within the DLCC. So we have a bibliography. We have a lot of other resources on there. So I encourage you to check in to the website. We also have the listserv that most of you are already on, and that's how you heard about this webinar. If you're not on the listserv, you can join that through the website, or just send us an email and we'll add you to the list. Any questions about that? Jeanette, do you have a question? Jeanette, do you have a question? You're unmuted if you want to. Okay, well, you can type in a question if you want. That's fine. Okay, we'll move along.
All right. Very good. Okay. Task 4 of this project, I hope you can hear me here, is to do a climate climate change risk assessment for the DLCC. And the DLCC, as I said, has 141 8-digit drainage basin HUCs in it. And onto that map, we are adding the distribution of springs, the distribution of springs-dependent species, the human population and population change data, and various projections of climate change that have been proposed by the USGS and other climate change modelers. Mostly those are global climate change models that are being downscaled to the local distribution of the local landscape. What this project interestingly provides, though, is information on endemic species within the DLCC. Endemism at springs takes place as a result of a prolonged evolutionary process, meaning perennial, typically deep water aquifer springs. Under such situations in, say, Ash Meadows, in Death Valley, in Montezuma's Well, and elsewhere in the DLCC, those long-term evolutionarily stable conditions promote endemism. One thing we can identify in this project then is which HUCs have high concentrations of endemic species that are probably related to deep aquifer springs. We also will be able to look at where other genera of those kind of species are distributed in the landscape with the georeferencing we're doing on those species. So within HUCs, we'll understand level of endemism at springs-dependent species, as well as the concentration of rare species that may be more related to shallower water aquifers, and we'll use those data along with this other information on human population change to look at the and the climate change risk models to evaluate how much climate change, global warming, and aquifer depletion will threaten those springs. So this is a process that will take place later in the project as we have compiled the data on springs and springs-dependent species, but we think it's kind of an interesting avenue to be able to explore climate change risk modeling for the landscape. So it'll be a HUC-based climate change risk model. And any questions about that? We ourselves have quite a few questions about it, so questions are welcome there, and we'll be continuing to explore these issues. Okay. All right. Moving on then. We'll have Jerry talk. We'll have Jerry now talk about collaboration in the DLCC. Oh no, sorry. I'll talk about collaboration in the DLCC project. Let me say that this is an effort that is really at a kind of a core mission project for the Spring Stewardship Institute. We are very much interested in improving understanding of springs and in improving the management of springs throughout the DLCC landscape, really throughout the world. What we hope is that by inviting everybody in to participate collectively in this project, it will enhance collaboration. It'll give people a common lexicon, a common language to begin to talk about springs. We hope to provide information to managers and people interested in doing research on springs to really foster greater attention to springs. Of course, we are very interested in making sure the information is secure, so that non-publicly available information it's the intellectual property of the owner of the spring. We want to make sure that's maintained here, and through this elaborate process of password protection on the database, so that if a land manager has a question about springs, yes, they can access all the information available on the springs on their landscape. However, that is not going to be open to the public or really to anybody without special permission. That being said, there are great advantages to being able to share information with researchers, with neighbors, with partners, to learn more about springs and springs-dependent species within drainage areas. So our effort here is to bring this information, make it available to everybody who wants to collaborate in this process. We're going to try to compile and maintain data across administrative boundaries, and then be able to provide that information in a secure way to those interested in it. We want to facilitate the contribution of data to this process, so if you have information, if you have references, if you have observations about springs or springs-dependent species within your landscape and are willing to share those, we would be very delighted to add that information into the database. We really want to encourage geocollaboration to maintain the ecological integrity of the aquifers, of the resources of those that occur at springs, and the sustainability of springs. Are there trade-offs for collaborators? Well, we think the opportunity to collaborate is worth more than the trade-offs at this point. What we hope is that trade-offs will be openly and freely discussed so that we have a good understanding of what those are. We'll post those results, any comments that come in on that, on the report on this webinar, and invite commentary on that. But we feel that it's about time we actually got down to brass tacks here and really put the information together so that interested land managers and spring stewards can have ready access to good information. And again, fully recognizing the need for data security here. We welcome your feedback and discussion throughout this process. Okay, I have a question about climate change predictions. Are we using local, regional, or national predictions? The predictions that matter, I think, most to us are the regional and HUC-based predictions that USGS out of Tucson have been producing for the HUCs of the Desert Southwest, and so that's going to be the body of the predictions will be regional and HUC-based. National predictions are, again, these are downscale global, so once you get to the level of the whole nation, there is some interest in relationships between latitude and elevation. Those might play out in that direction, but we'll be assembling the predictions across scale and evaluating how well they may play into the story of climate change risk modeling for the DLCC. All right. Now Jerry will talk about the next steps in our process here.
Yes, over the next few months, we're going to just compile feedback from potential collaborators and partners that we're already working with. We'll evaluate that, and we're developing a lot of these online tools iteratively, and we'll be reporting on that either on our website or at the next webinar or both. We will be continuing to expand our collaboration network. We have a lot of really great partners right now, and we're working on engaging others. We'll be compiling springs data and the springs-dependent species distribution data over the next few months. We'll be launching the online database for beta testing and feedback over the next month or two, and we'll be letting you know about that. We're developing more online web mapping applications. If you're interested in those, please get in touch with us. We also would like to know if there are other people that we haven't engaged. We have a mailing list right now of 230 people, and we tried really hard. We looked at the whole DLCC, and we looked at all the land managers that are associated with it and tried to get in contact with as many as we could, but we may be missing some. And so if there's somebody else that needs to be informed about it, then just pass the information along to us or to them. I'd really appreciate it. The next webinar will be tentatively April 16th at 2 o'clock, and if there are some big glaring conflict with that, then we may change it, but that's the tentative date. I did want to let you know that this the listserv is secure and it's moderated, so if anybody sends anything to the listserv, it's moderated before it goes out. So our goal is to minimize the number of messages that you receive, so you won't be inundated with too many. So, are there any questions about? There was a question somewhere. There are 5 questions. Yes, we are planning to collaborate with the USGS. One thing about some of these unmapped springs, we found that these are some of the most extraordinary places, and it's possible that they're in really good ecological condition simply because they are not mapped. It's not our intention to make this information public or publish these maps to the general public. It's important to know where they are. It's important for land managers to know where these springs are, because you can't protect something if you don't know where it is. On the other hand, they are afforded some protections simply because they're not mapped. And we're definitely open to discussion about that. Some of these springs we've just found as we've been walking, we're in the field on our way to survey a spring, and we pass by 3 others, and we add those to the map. So I'd be really interested in hearing your opinions about those unmapped springs. We are very Joseph asked about our interest if it extends beyond the desert LCC. Absolutely. We did apply for an LCC grant in the Southern Rockies, and we did not get that one. We were really happy to get this one. But we'll be applying for the Southern Rockies again. As we're compiling this information, as we're compiling springs data, we are we end up compiling data beyond the boundaries of the LCC, and it doesn't make sense for us to clip that off. So we are ending up with a lot of data that extend into, I think I checked the other day, and we're extending into about 7 or 8 surrounding LCCs. So we're definitely interested in the boundaries beyond the LCC.
All right. We also have a question about does your project include any sort of functional conditional assessment index of biotic integrity that land managers can use to assess the physical, biological, and chemical condition? On our website, we present what we call the SEAP, the Springs Ecosystem Assessment Protocol, which is exactly that. It's a quantitative approach to evaluating the ecological integrity of springs, the extent of human impacts on them, and the administrative context. Oftentimes what we find is if you plot the quantitative scores of human impacts on the springs against their ecological condition, it's a strongly negatively sloping line, but springs that show up as being of high ecological quality and high risk are places that managers pretty naturally are drawn to as sites that might need management attention. So we provide those tools on our website. We'll probably present a whole webinar on the subject of assessment as we go along here, and that's certainly a topic that we go into in great detail in our workshops as well. And we would present that at the Las Vegas workshop next fall, if you care to join us on that. So yes, absolutely, that's a very important element of the work is to move beyond just information and provide a way of quantifying risk assessment at springs for the purposes of management. So once again, yes, we're interested in going beyond Arizona's boundaries. This project is the whole DLCC. We're really trying to map springs and springs-dependent species across the entire DLCC landscape from southeastern California into southwestern Texas. All right, we're paging through the questions here and trying to find anything else that might be relevant to the whole group. We will put a copy of this webinar presentation up on the website, and with it a copy of the report, including the kinds of questions that that are coming up here. So that hopefully will all be available. Please feel free to comment on that report. And another question here is, will your project include any sort of wetland, riparian classification plant associations for these springs ecosystems? And absolutely, we spend a pretty phenomenal amount of time trying to document the concentration of wetland plants and plant species in general at springs. One kind of little tidbit on that is we just finished 3 projects, one in northern Arizona, one in southern Nevada, one in Alberta. In each case, we were able to inventory 50 to 90 springs. Total habitat area inventoried then 10 to 15 acres for each of those landscapes. In each case, we found that 18% to nearly 25% of the species in the entire region were found at those few springs. This harks back to the issue of species packing at springs. Springs are loaded with species. They're very tightly packed because of the access to water and soils oftentimes at springs. Springs are places where soils form in the Southwest, which is quite unusual in the Southwest, and therefore plant species are very tightly packed in those landscapes. We don't know of any place, any other kind of habitat you could go into and find 1/4 of the species in the landscape in a tiny habitat area. So we're very concerned with plants, the plants there. Another challenge, of course, in that realm is that vegetation mapping is done on a large landscape scale. Springs usually fall, are usually quite small. They fall within the pixel size, and they get kind of overlooked in those landscape mapping and vegetation mapping exercises. So, for example, a recent work in Grand Canyon, the Park Service there has mapped more than 200 plant associations, and we're in process on trying to figure out how springs vegetation relates to that classification system they've got for vegetation there. Plenty of adventure and good research to be done on that topic. All right. Another question is,
if we share our data with DLCC, is this in lieu of storing data on STORAD or another national database? And I would say that there is great value in having a national data set such as STORAD. However, our database allows us, because we have water chemistry, flow, flora, fauna, solar radiation, the assessment, geomorphology, we're able to analyze the relationships that are quite complex between all those different characteristics of a spring. And so having it all in one data set across administrative boundaries is really of great value. So we're not dismissing the value of STORAD, but it would probably benefit us all to have that information in both places.
The relevant information can be stored on STORAD, and we have this interactive process with our database that we are quite confident that you'll find really wonderful, easy to use, and very responsive to your questions. Another question here is the training in September going to be different from a training we would have attended last year? The training in September will include the online application portion of this new database. So, in addition to the concepts that we present at our normal workshops, there'll be more detailed training for managers into how to use the database, how to get information and reporting out of it, and that'll take up proportionally more time than we usually devote to information management at a normal Springs workshop. The concepts that we present, however, will be similar. the field trips associated with that will be pretty fun too, because we'll go to Restored Springs and to some of the desert southwestern springs that are so world-renowned in that region. Okay.
No, I think we're.
Okay. I think that answers most of the questions that we need to attend to in terms of the overall group, and we're nearing the end of our time here. So I would like to thank you all for your time and attention to this issue. We hope that the presentation here is informative, and what we really hope is that this will stimulate you to consider collaboration in this project. And we will make every effort to attend to all the issues of data security, as well as compiling your information into a reliable, usable, and easily accessed information source. So with that, I thank you very much for your time today, Jerry and I. Have really enjoyed putting this together, and we look forward to your attendance at our April webinar as well. So thank you very much, and good afternoon.